Hello students, in this video we are going to learn about how to represent a graph by means of matrices. Okay, we are going to represent a graph by means of two types of matrices. Okay, the one is adjacency matrix and the second is incidence matrix. As we know earlier, adjacency can be talked between either two vertices or two edges. And when it comes to incidency, it is talked between a particular vertex and an edge. Okay. So, as an adjacency matrix, we are going to discuss the adjacency between two vertices. And in case of adjacency matrix, we are going to discuss about the incidence relation between a vertex and an edge. Okay. So, we shall get into the topic now. So, first we are going to learn about adjacency matrix. Okay. So, let G equals V comma X be a P comma Q graph. So, the graph G has P points and Q edges. Okay. So, let V equals V1, V2 up to etc. Vp be the vertices of the graph G. Okay. So, now an adjacency matrix for this graph A is a P cross P matrix. Okay. So, where P is the number of edge vertices of your graph. Okay. P cross P matrix. So, that is equal to Aij, and the matrix elements of the matrix is defined as, see, the element Aij of the matrix will be equal to 1 if the vertex Vi and the vertex Vj are adjacent to each other. Okay. The element will be 0 if there is no adjacency between the vertex Vi and Vj. Okay. So, this matrix defined in this way is called an adjacent matrix. Okay. So, let us get into the problem. Okay. See, here we are given a graph G with a vertex set V1 and G1. Okay. So, the graph is given as this way. Okay. So, where V1 is equal to, V1 is a vertex set of this particular graph and the vertices are V1, V2, V3, V4, V5. Okay. So, for this particular graph, we are asked to draw the adjacency matrix. So, the adjacency matrix is defined as A. Since number of vertices is 5, it is going to be a 5 cross 5 matrix. Okay. So, let me take like 1, 2, 3, 4, 5. So, the vertices are taken in this way, and in columns also the vertices are taken in this way. Okay, right. See, this is the position. Okay, so I am considering the vertex. Okay, let this be V1, V1, V2, V2. Okay, so instead I have written 1, 2, 3. Okay, so wherever I have 1, 2, 3, it represents V1, V2, right? Fine. So, this element V1, V1 will be 1 if there is an adjacency between V1, V1. Okay. If not, it will be 0, right? Since there is no loop here, no vertex is incident with or no vertex is adjacent to itself, right? So, what happens is the diagonal entries will all be 0. Since there is no loop, all the diagonal entries will be 0, right? Now, coming here. So, V1 is adjacent to V2. See, listen, V1 is adjacent to V2. So, I'll mark 1 here. V1 is adjacent to V3. So, I'll mark 1 here. So, V1 is not adjacent with V4 and V1 is not adjacent with V5. So, I have drawn 0, 0 there. I marked 0, 0 there. Now, coming to V2. Is V2 adjacent to V1? Yes, V2 is adjacent to V1. So, I'll mark here 1. Then what about V2 adjacent with V5 and V4? Okay, V2 is adjacent with V5 and V4. So, I'll put 1 here and 1 here, but not with V3. Okay, now taking V3, where is V3? V3 is here. V3 is adjacent with V1 and with V4. So, V3 is adjacent with V1 and with V4. So, the remaining elements will be 0, 0. Okay, and coming to V4, V4 is adjacent to V2, V5 and V3. V4 is adjacent with V2, V5 and V3, right? Okay, so all the places are 1 and the remaining elements will be 0. and V5 is adjacent with V2 and V4. V5 is adjacent with V2 and V4. I'm sorry, so it should be 1, right? So it should be 1. V5 is adjacent with V2 and is it adjacent with V4. So remaining elements will be 0. So this gives the adjacency matrix for this particular graph G. Okay, right? So it is very much easy to represent the graph by means of a matrix. Okay, from this adjacency matrix we can learn some properties, or we can have some observations. Okay, since all the there is no loop is allowed, see, all the diagonal elements are 0, right? And one more thing, this adjacency matrix is a symmetric matrix. See, if V1 is adjacent to V2, then V2 is also adjacent with V1. So this element is 1, this element is 1. If V1 is adjacent with V3, then V3 is also adjacent with V1. So the matrix is going to be a symmetric matrix. Okay. So this is the second observation. Then one more thing is, see, take V1, consider this vertex V1. What is the degree of V1? It is 2, right? So in the column V1, you will have only exactly 2 ones. Similarly, in the row V1, you will have exactly 2 ones. Okay. So the sum of elements in this row, okay, sum of the elements in this row is 2. The sum of the elements in this row is 3. The sum of the elements in V3 is 2. The sum of the elements in V4 is 3. The sum of the elements in V5 is 2. All these numbers represent the degree of that particular vertex. See, degree of V1 is 2, degree of V2 is 3, degree of V3 is 2, degree of V4 is 3. I'm sorry, V3 is 2, V4 is 3, and V5 is 2, right? So the sum of the elements in the particular row, since the matrix is symmetric, even in column, see here it is 2, 3, 2, 3, 2. Okay, so the sum of the elements in ith row or the ith column represent the degree of the vertex Vi. Okay, so this is the observations that we can make from this adjacency matrix. Okay, so it is a symmetric matrix. Then the sum of the entries in particular row or column gives the degree of that particular vertex. Okay, so this is all quite important results to be noted. Okay, let us move further. So this is the things that we have observed. See, so the adjacency matrix is symmetric. The sum of the ith row or ith column is equal to the degree of the vertex Vi. The entries along the principal diagonal is always 0. So that is the observations that we have made. So this is all about your adjacency matrix. Okay. Now let us move further to the incidence matrix. Right. So incidence matrix is for between the vertex Vi and the edge. Okay, so incidence is always discussed between vertices and edges. So let us go further. Okay, let G equals V comma X be a P comma Q graph. Okay, P comma Q graph, right? So where V is equal to V1, V2 up to etc. as Vp, it has P vertices, and X is equal to X1, X2, X3 up to etc. as Xq, it has Q edges, right? Then in that case, your incidence matrix is a P cross Q graph. Okay, I'm sorry, P cross Q matrix, which means that your vertices are taken in rows and your edges are taken in columns. Okay, up to etc. Xq, it is taken in columns. Okay, so now how we are going to define the entries of the matrix? So that is what important. Okay, so the matrix B is Bij, where the entries is Bij equals 1 if the, see, Bij, okay, the suffix Bij equals 1 if the vertex Vi, don't change the order, if the vertex Vi and the edge Xj are adjacent, okay, I'm sorry, or incident with each other. Okay, if the vertex Vi is incident with the edge Xj, okay, and it will be equal to 0 otherwise. See, Bij means Vi places the vertex role and J is for the edge role. Okay, so don't change the order of it. So this is how we define the incidence matrix. Okay, so this is called the incident matrix of a graph G. Now let us discuss the incidence matrix for a graph G. So this is actually the incidence matrix for the previous graph that we have discussed here, right? Okay, so let me draw the incidence graph here and we shall cross check with that. So for this we are going to draw a incidence matrix. So incidence matrix here we will have vertices, right? So this is B equals, okay, vertices, and here you will have edges x1, E1, okay. Here I have taken as E1, E2, no issues, either X or E, okay. V4, V5, E6, I think we only have 6 edges, okay, right, 6 edges are taken, okay. So now, see, listen, V1 is adjacent with E1, so I'll draw 1 here. So V1 is playing as end vertex for E1 and E2. So for E1, E2 there will be 1. So is there any other vertex edges out from V? No. So corresponding to V1, all the other elements will be 0. Now let us go to V2. Okay. From V2, you have V2 is the end vertex for E1. So E1 over 1. And it is for E4. So for E4 there is a 1, and it is also for E6. For E6 there is a 1. Okay. So these elements will be 0. Okay. Now coming to V3, right? So here it is your V3. E3 acts as a incident vertex for E3 and for E2. So for E2 and for E3 it will be 1, and the remaining elements will be 0. Now coming to V4. So from V4 we have E3, E5, E4. E3, E5, E4. Okay, all are there. So remaining elements will be 0. Okay, now coming to V5. V5 then we have V4 and V6. I'm sorry, V5 and V6. So all the other entries are 0 here. Okay, so this is the incidence matrix of this particular graph. Okay, this is the incidence matrix of this particular graph. See what observations we can make out of these incidence matrices. Here this matrix is not symmetric matrix. First, symmetric matrix can be discussed only for a m cross n matrix, for a square matrix. This is actually not a square matrix. This is actually a 5 cross 6 matrix. So the concept of symmetricity cannot be discussed here. Okay, so what else we can discuss is, see, if you are considering one particular edge, okay, for this particular edge E1, right, E1 is with V1 and V2, okay, so it will be having only 1 and 2 vertices, corresponding to 2 vertices la mattum da irukum. Edge E2 consider pannona, it will be adjacent with only, incident with only 2 vertices, okay, so it is an incident with V1 and with V3, so only in V1 and V3 it is having 2 ones, okay. So E3 edutona, it is having 1 in V3 and V4. E4 edutha, it is having 1 in V2 and V4, right? Similarly for E5 you have 1 in V4 and V5. For E6 you have 1 in these two places, okay. So each column, okay, each column will have exactly 2 ones, okay. Each column will have exactly 2 ones, as each edge is incident with exactly 2 vertices, okay. And similarly see, V1 is incident with 2 edges, okay. So sum of ith row, right, sum of ith row, not column, sum of ith row gives the degree of that particular vertex Vi, okay. The sum of the ith row gives the degree of that particular vertex Vi. So here the degree of vertex is 2, vertex V1 is 2, degree of the vertex V2 is 3, yes it is 3, degree of vertex V3 is 2, the degree of the vertex V4 is 3, and the degree of the vertex V5 is 2. Okay, so this is the observations that we can make out of the incidence matrix. So the number of ones in each column will be exactly 2, and the sum of the elements of the ith row will be equal to the degree of the vertex Vi. Okay, so this is the observations that we can make out of this incidence matrix. Okay, so this is the matrix that we found, and this is the observations that we have for the incidence matrix. Okay, so here I'm giving you some problems for matrices, adjacency matrix and incidence matrix. So you can take this as homework and you can complete these 2 problems. Okay, try to find the adjacency matrix and incidence matrix for all these things. And the second problem is like, if one row of the incidence matrix, okay, if one row of the incidence matrix of a graph has all its entries 0, what can you say about that particular graph? Okay, just try to have such graph and find your observation. Okay, So this is all about the matrix representation of the graph. Thank you all.